Okay, so here we're going to be comparing the ratio of volumes of two different shapes. And this comes in handy when you're increasing or decreasing certain solids by percents. You want to see what the actual volume increase is going to be. So step number one, it says a food company distributes its tomato soup in 2 cans of different sizes. So cans, we can assume, are cylinder because that's our common concept of cans. Different sizes. So we have a smaller can, and then we have a larger can. It's kind of like Safeway size versus Costco size. It says for the larger can, the diameter has been increased by 25%. So we have here the diameter has been increased from one to the other 25%. The height remains the same. What percentage does the volume of the can increase? So we're going to be comparing the volume of the first can to the volume of the second can from this when we increase the diameter by 25%. Okay, so step number one. The volume of the first can is going to be area of the base times the height. That's for any cylinder, but our base, we know because it's a circle, is going to be pi radius squared times the height. And that's the volume of the first can. The volume of the second can is also base times height, but our base here is going to be pi, and then we have here our radius squared, but it's going to be 25% greater, so technically that's going to be 1.25 r, and that is going to be squared times the height. And so we're going to be taking our 1.25 r squared, so 1.25 times 1.25, and we end up with 1.5625. So here our volume of 1 is going to be pi radius squared times height, and our volume 2 is going to be pi 1.5625 times whatever the radius squared is times the height. So we know that our volume, if you compare here, this is 1, this is 1.5625. So if 1 represents 100%, 1.5625 represents, we move the decimal over twice, 156%. So the difference in the volumes of 156% and 100%, which is our original volume, it is increased by 56%. It says round your answer to the nearest percent, so it's going to be 56%.